have signature particles, which is the smallest amount of energy that can be put in or taken out of that particular field. Now, these three fields, they have different amounts of electric charge also. This one is a plus charge, this one is a minus charge, but Zachary, unfortunately, is neutral. He has no charge whatsoever. And now, from their mother, they got the spin 1 property, but their father, the Higgs field, was positively charged. It was the only field in the early universe that had positive energy. All of the other fields did not have positive energy. So his input to this coupling was to have these children of the coupling appear with mass. Now, the two W fields had a mass of 80, but the Z field had a mass of 97. And the amount of mass is a measure of the intensity of attraction between the two parents. The local gauge field and the Higgs field has a certain degree of attraction. It's called their coupling attraction, or their coupling constant, as we would say. And different fields have different amounts of attraction for each other, so they have different coupling constants. And the amount of attraction is the determinant of how much mass ends up in the child fields. Now notice that Higgs still has one unused component. Three of his components mated with the three receptors in the local gauge field, but he has one component as yet unused. So what he does is a little bit of self-coupling on that, and he comes up with a Higgs junior field. And since this is entirely on its own, then it also has a signature particle of a spin 0. And it has a mass of equal to 100 plus. That's about as near as we can guesstimate it. Now, the Higgs field does not mate with the global gauge field. It knows that if it mates with the global gauge field, it's going to produce some children that have no mass. So it avoids doing that, and instead it's attracted to the local gauge field. So let's explore this mechanism, which is known as the mechanism, in a slightly different view. Let's suppose in the early universe, this is the temperature level. Let's represent it as a water level, if you wish. And as the temperature rises, as the temperature goes down, the universe gets colder, then the water level goes down. Now, up here at the top of the water level is Higgs, just resting in high temperatures. And over here is that cute little local gauge field that he comes to like so much later. Here we have a global gauge field. Here we have an electron field. And here we have a quark field. Now, none of these fields have any mass at this point. And this is the edge of the universe, if you will. And this is the bottom, ground zero. Now, as the temperature comes down, then the water level comes down, and all of these fields start to reach ground zero. And this is what the ground looks like. Sort of level, sort of low level, and then it has a huge spike here, sort of level there, sort of level over here too. So this is the profile of the ground at this particular time. So as the temperature drops, or in our schematic drawing, as the water level drops, then all of these fields come down, down, and down. And that cute little local gauge field ends up here, the global gauge field ends up here, and the quark mass, the electron field ends up there, the quark field ends up there. But unfortunately, Higgs ends up right here. And now the temperature field is gone, everything's cold, and this is where all of our participants are. So down here, they sort of just start playing in a new existence, playing around their zero energy levels. But Higgs is in a bit of a quandary. He's saying, looking around himself, and as he looks in every direction, he sees exactly the same thing. So he's in a position of what we call global symmetry. Everything is symmetric about himself. He's also in a state of positive energy, because here he is on top of the mountain. All the other fields are at zero energy, but he's at positive energy. But he's very, very nervous and very concerned and very worried, because he knows if he makes the slightest misstep, or if he goes to sleep, or the least little thing happens, he's going to spontaneously fall down that mountain. And when he reaches the bottom, he's going to be traveling so fast with so much energy, he's going to have a terrible result. And he's very apprehensive about that. So he's worried in his state of positive energy. But these fields down here, they notice that he has a positive energy, which they don't have. And they're strongly attracted to it. So all of them, with as much zero-point energy as they have, try to scramble up the mountains and say, Higgs, come down, Higgs, come down. And of course, he's attracted to them, so that's another motivation perhaps for him to come down too. But still, he holds out in his position of global symmetry, but he cannot hold out forever. And what happens is he does slip. He makes a spontaneous slip, and spontaneously he breaks this global symmetry, and he starts to go down the positive energy mountain. Now, as he goes down the mountain, it's quite apparent that not all directions are the same to him anymore, because in the direction behind him is a mountain, and not in any other direction. So he's broken his global symmetry, broken it spontaneously by slipping and falling, and he's on the way down to a lower energy level, and extremely apprehensive about it. Because as he goes down the mountain, he gains more and more energy, and he knows what's going to happen when he hits the bottom. It's going to be very, very damaging, so he doesn't want that to happen. These massless energy fields, they see this positive energy coming down, and of course they're attracted to it, so they all try to run up the mountain and say, Higgs, me, over here. And so what he does is the only thing that he can do. Here we have the cute little gauge field coming up the mountain about there. Now Higgs knows, because he knows the equations, that if he mates with this gauge field, couples with it, then he can transform his energy of falling into mass of his children. And once he has released himself of his energy, then he will be hardly moving at all when he hits the bottom and will cause no damage. So he knows that's the only thing that he can do. So what he does is he couples or mates with a local gauge field and transfers his energy, his positive energy, into the mass of his children fields. And therefore he has less positive energy himself, and he is not going to have the same damage. Now he doesn't choose the global gauge field because he knows that would produce massless children, and he has this problem that he has to solve. So he does do that, and the three child fields are produced, which we know was Walter, Wanda, and Zachary. And they had these masses, 87, 87, and 97. And they're all spin 1, as was their mother. And he also produced the Higgs Junior field, which has a spin 0, just like he does, because he did this one all by himself. And it has a mass of 100 plus, all coming from him, his positive energy. Now, the astute among you already have an objection, because as the equations tell you, and as I mentioned, and as you know, the mass of the children fields is determined by the coupling constant, or the amount of attraction between the two coupling fields. Now, there's only two coupling fields, so they're only going to have one coupling constant of attraction, and so all of their children should then have one mass. But notice, only 2 of their children have one mass. The third child has a different mass. How did that happen? Well, I'm afraid that it's too easy to tell. I've spared you the worst, but now it has to come out, because the truth comes out in the children. There was another local gauge field, and Higgs mated with both of them. simultaneously and at the same time. And the first cute little gauge field only actually had 2 receptors, 2 degrees of freedom. And the new mentioned local gauge field had 1. So by mating with both of them simultaneously and at the same time, Higgs was able to produce 3 offspring, 2 of them having the mass represented by the coupling between Higgs and the first local gauge field, and the other one having the mass represented by the strength of attraction between Higgs and the other local gauge field. So Higgs turns out to be this type of a guy. I mean, alpha male, extreme, stud. And it's not over yet. Because in the rest of the way down the mountain, he called over the electron field, coupled with the electron field, and gave the electron field some mass. Then he called over the quark field, and coupled with the quark field, and gave the quark field some mass. So when all was said and done, then the Higgs field, by dropping off of its positive energy mountain, created massive fields of 1, 2, 3, 4, 5 massive fields, plus Higgs Jr. making 6 massive fields. So this is the mechanism that is known as the Higgs mechanism. And the equations for it were derived by these 6 individuals that I mentioned. And it was a historic moment in field theory, because field theory became reputable. It's our major theory right now, so this is a major contribution. These 6 individuals, by giving the equations by which the Higgs field transfers the positive energy at the early universe into the mass of 6 other fields, their derivation of these equations is a massive contribution.